The uses of concave mirror. So this is mentioned in class 10 CBSE. This is 10 CBSE topic, and this is an important topic where students sometimes they feel difficulty that where exactly the concave mirrors are used and why they are used like that. So we'll see this. So this is an exact paragraph from the NCERT. So the concave mirrors are commonly used in torches, searchlights, and vehicle headlights to get powerful parallel beams of light. Let us go one statement by one statement. So to get powerful parallel beams of light. So the powerful parallel beams of light in the concave mirror are generated when the object is placed at focus and the position of the image is at infinity. The size of the image is highly enlarged and the nature of the image is real and inverted. Okay, so we can say this, that when the object is placed at focus, at focus, then the image is formed at infinity. And the most important thing is, if you can see that all the rays, after reflecting from the concave surface, they are emerging parallel to each other. So there are two rays being shown here, one which is parallel to the principal axis and one which passes through the center of curvature. So both the rays, they are parallel, and in fact all the rays are going to be parallel. If suppose this ray also, if we take, so this ray also will be emerging parallel only. This ray will also be going parallel only. So all the rays are going to be parallel when the object is placed at focus. This is again another diagram, ray diagram, to like very clearly demonstrate this phenomenon. So now what happens is, in torches, searchlights, and vehicle headlights, what happens is that this object or the bulb is placed at the focus, and all the rays, they emerge parallel to the principal axis, and we get a beam of light. A beam means rays which are parallel to each other. So here also we can see that this object, which is the light emitting bulb, is placed at the focus, and then all the rays, they emerge parallel from the torch. So therefore the torch is, so if you see this torch, the torch has this surface as the concave surface. It's a concave surface, and it's concave reflecting surface. So this surface, which is like behind the bulb, it's basically a concave reflecting surface. So therefore the rays which emerge, they are coming out as parallel beams, powerful parallel beams. And this is one example also which we can see. So that is the torches. Then there is searchlight. Searchlights are like bigger torches, and then we can see one of the searchlight which is there in helicopter also. This is again a searchlight. This is again a searchlight. And we can clearly see that the person has got searched. And even in the vehicle headlights also the same thing is happening, that the bulb is placed at the focus and we get powerful beams of light, parallel beams of light. So this is the vehicle's headlight. So that was the first thing. When powerful parallel beams of light we require. So for vehicles we require, especially when in the night time, to want to see and go ahead, the helicopters, or they require to search for people and all, like that. Second thing, this is a second principal use. They're often used as saving mirrors to see a larger image of the face. The dentists use concave mirrors to see larger images of the teeth of patients. So now in this, if we see larger images of the teeth of patients, so this is a plane mirror, and the plane mirror, when it forms a virtual erect image, the image is of the same size of that of object. Okay, the image is same size. This is, I'm talking about parallel plane mirror. Okay, so the size of the image is same as the size of the object. Now for a convex mirror, for a virtual and erect image, we have the image is diminished, it is of a lesser size. So convex mirror gives us a lesser size of the image, plane mirror gives us the actual size of the object. There is only concave mirror which gives us an enlarged virtual image of the object. So it's virtual and erect, and it is behind the mirror. This is the ray diagram for it, where this is the object and the image which is formed is erect, but it is enlarged. In the case of plane mirror, the object forms an image which is erect, but it is of the same size. In case of a convex mirror, it is of a lesser size, it is diminished. Okay, but in case of a concave mirror, it is enlarged. Okay, and in certain things we require to see our face, or we require to see our image as enlarged. Like one of the examples is this. Here also one of the examples is this. Okay, here also, you know, the dentist also, they use concave mirrors to see larger images of the teeth of patients. Now this is the last one. Large concave mirrors are used to concentrate sunlight to produce heat in the solar furnaces. So what is the property used? The property is, when the object is at infinity, the position of the image is at focus. Okay, focus F. The size of the image is highly diminished, point sized, and real and inverted images formed. So now if you see, what happens is that, let us say, you know, this is the sun, this is the sun. Okay, and all the rays of the sun are, like, you know, they are coming, whatever, you know, the concave mirrors aperture is there to catch. So this is the aperture, like, you know, the opening, this is the aperture. So all these rays, they come and they get concentrated, they meet at the focus, they get concentrated and they meet at the focus. So that means what? Whatever intensity, you know, whatever heat was there, which was spread throughout the space, you know, of the concave mirror, you know, how much, you know, concave mirror has received, all of that gets concentrated at the focus. Okay, so sun's rays, like when they are dispersed, they may not be able to cause, you know, a fire. Okay, they are like quite hot, but doesn't necessarily, it doesn't, you know, it doesn't cause fire. However, when they get concentrated, then the heat raises, the temperature raises, and that may lead to, you know, fire, and we actually generate heat out of it. So this is an industrial solar furnace. That's the world's first industrial solar. So you see, what is this? This entire thing is basically a concave mirror. Okay, this is huge. It's like, you know, you can see 1 2 3 4 5 6 7 8. It's an 8-storied, it's 8-storied building, and the entire thing is a concave mirror. And this you know, this particular, you know, like setup is placed at the focus, and here when all the rays are getting concentrated, this particular setup, it uses all the rays to generate heat in order to even melt steel without fuel or electricity. So much heat is generated. Okay, so this is okay, so this entire thing is basically a concave. It's a concave reflecting surface, or we can write a concave mirror. Okay, so this is the solar furnace. This is the mechanism. So all the rays which strike this concave mirror, they converge here. Okay, and this leads to the boiling or the melting of the iron or the steel. Okay, it can also be used for simple cooking and all, that also can be used. Okay, so these are the uses of concave